It
Maybe
looks
not.
like it is to me.
Oh yeah, because I can stop or okay, pause or stop. So it must already be recording. Cool. Okay, so welcome everybody. Thank you so much for being here for our March WUG. It's our Wednesday WUG. So Werewolf is an open source stateless provisioning system for managing HPC clusters at scale. It enables administrators to boot and manage compute nodes over the network without local disks, making it quick and simple to deploy everything from small research clusters to massive top 500 systems. Originally pioneering the concept of stateless node management over 2 decades ago, Werewolf version 4 has evolved to integrate modern container technologies, allowing you to provision containerized operating systems directly to bare metal. It's vendor agnostic, highly scalable, and designed to make managing hundreds or thousands of nodes as straightforward as managing just a few, which is why it's become an industry standard backed by OpenHPC and used across universities, research institutions, and enterprises worldwide. Welcome, everybody. Today, our conversation starter is going to be Josh Burks from ASU, and the topic is ZFS storage with Werewolf. So let's go to the next slide. Cool. And it just does it. I love that. Okay, so my name is Rose Stein. I'm the community manager here in the Werewolf project. I also work at CIQ, and I am happy to be here and kind of hosting and help set up this WUG. If you need anyone added to the WUG, you should be able to do it on your own, like in a Google Calendar type thing. But if you need any help, just message me. No problems. Jonathon Anderson is our technical steering committee lead, and he's going to be doing project and community updates. And then, as I said, Josh Burks from ASU is going to be getting our conversation started with ZFS storage on Werewolf. And then, of course, we're going to have open Q&A. So if any kind of, questions, ideas, concerns, opinions come up in your mind, feel free to jot them in the chat, drop them in the chat. There's lots of people here who also have opinions and they'd love to chat with you more, especially in the Q&A section or the conversation section. Just remember, Zoom has kind of changed some things. So if you just start typing, it ends up being in the notes part, but you want to click the little icon thing so that it goes to everybody. Okay, so that's good. Let's go on and thank our steering committee. These are the people behind the scenes and sometimes front of the scenes that you see that are kind of responsible for the code part. If you have any issues or concerns, they kind of take them up and steer the direction of the project. So thank you to Gregory Kurtzer, who is the original founder of Werewolf, of course, Jonathon Anderson, current technical lead, Christian Gall, Timothy Middlecoop, and Jeremy Seidel. And what's really cool about this project, such a thriving, wonderful project, and it's maintained by people from all different places, organizations, and persuasions. And if you want to go to that meeting, so the technical steering committee meeting happens twice a month on the first and third Wednesdays of the month via Zoom. So if you want an introduction to that, you can just post that in the chat here or in the Slack. We do have a thriving Slack. We're up about 10 members just since last month on Slack. On YouTube, we're up 1 subscriber since last month. So we're making progress. Blue Sky and X just kind of stays steady at 32 and 29 followers. Okay, so that's it. Again, thank you to everybody who participates. So every question, every comment, every pull request, every, hey, this is a bug, what's happening over here, all of the activity that happens inside of the Slack and GitHub, we very, very, very much appreciate it. So thank you for being part of this project, every single one of you. Okay, so now it's time for updates with Jonathon Anderson. I imagine you'll need the screen share, yeah?
Yes, please. All right. All right. So a little bit more to talk about this time than last time, which is good news. So people that were here in the last, I think, couple WUGs will know that we've been working on this PR that Christian Goal originally submitted for adding TLS support to the Werewolf daemon, the Werewolf D server. And so this is at least initially primarily to protect access to the the runtime overlays, which are expected to contain, authentication credentials and other secret material that you don't want exposed. That was all going over plain HTTP before, so now we have an HTTPS server and ways to manage the certificates for that. And that was merged in last night. Thank you, Christian, for reviewing my review of your review and PR and all of that. So it's gone back and forth. So that's in main. But as we were doing that work, there was a lot of touching of the Werewolf server and modification of the Werewolf server, and it's not been a great that specific piece of code where the HTTP server is has not been our favorite bit of the code in the past. So we were like, if we're going to be changing this, let's take this opportunity to clean it up and make it a little bit better. So that has also been done. But as that was being done, we were like, this is kind of a big enough change. Let's stop calling this v4.6.6 and just call it 4.7. So, first thing is that with the server rework, we've also added a new page to the documentation. There's also a security one, I think. Yeah. So the TLS stuff is documented here in this security section, but there's also a routes section. Um, where we've documented how the server works, what URLs are acceptable on it, what it responds to, as well as some things that are still there, but we're hoping to consider deprecated and have new routes to the same functionality in the server. It's all quite a bit more understandable and maintainable, which I'm pretty excited about. There are kind of a couple more dark corners of the code right now that we're looking forward to cleaning up, but this is one of the bigger ones. So it's in a much better state now. But that does mean that the release that we're working on is no longer 4.6.6, but is now 4.7.0. We're narrowing down pretty close on like this looks like a little bit bigger than it actually is. Some of these are doubled up because there's an issue and a pull request for it. And then a lot of these are relatively small. The biggest thing was this TLS work, and now it's behind us. So I'm excited to hopefully get this release out pretty soon. Um, Two more things that also got merged recently. One this morning and one overnight. So we've documented our policy for what Golang version we're going to support. And past, we've been pretty reticent to update this. It's relatively easy to see what versions of Golang are supported in Rocky 8 and Rocky 9 or Enterprise Linux 8 and 9. And then SUSE Enterprise, we build with Leap. Uh, is it 15 or 17, Christian? I forget now which one it is. What is current?
16 is current
A 16.
and
Oh, so maybe
16
we're
is
behind
current.
on
Yeah.
it.
16
Okay.
is the, yeah.
Okay. Well, in any case, we build with Leap, we build with Enterprise Linux, with Rocky, and then but one thing that we haven't had as much visibility into is a distribution called OpenEuler that is supported by OpenHPC, and they have historically been behind on Golang and have prevented us from updating to a more recent Golang because we don't want to break the ability to build there. But we've recently confirmed with OpenHPC that they're getting a more recent Golang version from like a supplementary repository for OpenEuler. So everyone is able to build, including back to Rocky 8 with Golang 1.25, which is a supported release again. So we've documented how our decision making works for that. And then in response to that decision, we have updated to 1.25, updated some of the build system to enable that because there were some incompatibilities going to 1.25 that broke some of our tooling. And then also, I think, have closed every known Dependabot and Snyk like issue that had been raised. So CIQ uses a piece of software called Snyk inside of CIQ for vulnerability scanning, and we have that pointed at the Werewolf open source code base. And then we have GitHub itself configured for Dependabot. All of that should be in a good state now, which I think is the first time we've had all of that closed out since I started working on the project. So I'm really excited to get that out in 4.7 and yeah, get that in people's hands. So far, we haven't had any issues with it continuing to work. It's working after the TLS work. It's working after this work was done. I've been able to boot it in both stateful and stateless and both single and two-stage configurations without issue. So We might, because it's a feature like it's not just a third digit. We might put out a release candidate release, but that hasn't been put out to the TSC yet, so we'll have to make that decision in a moment. This is all very recent. These just got closed out overnight. So happy to take any questions about that. Like I said, we've got this milestone left. If there's something that you would like to see included in here, feel free to ping anyone in the development channel, and we'll try and get it in. But I also want to, release early and release often, and we're already not as good at that as I would like. So we'll try and keep scope from creeping too big. But any questions on any of this?
Yeah, feel free to just unmute and ask if you
Yeah.
have something or a comment. I did see Josh gave a clapping hand
Yeah.
thing, so that seemed like a good thank you to me.
Or put stuff in the chat if you would rather do that than speak up.
Sure,
That's
of
fine too.
course.
Yeah, very nice to get all that Dependabot stuff closed. We recently have an internal repo that started getting Dependabot stuff in there, and gets cluttered very quick.
Yeah. All right. Well, thanks all.
Yep.
I'll
Thank
hand
you,
back to
Jonathan
Rose.
and team. Yeah, very good. Okay, so I am going to go back to my share screen because Mr. Josh does deserve his own little moment in the spotlight. So next up, we have Josh Burks, HPC Systems Analyst at Arizona State University, where he's been working hands-on with HPC infrastructure for the past 3 years. Before ASU, Josh cut his teeth in manufacturing IT at Intel, supporting high availability automation platforms. So he knows what it means to keep critical systems running. Today, he's bringing that operational depth to a topic that a lot of us have been curious about, running ZFS storage with Werewolf. Josh, take it away.
Yeah, thank you, Rose. That was a great introduction. Let's see if I can share the right screen here.
If it was off, you need to update your LinkedIn profile, just letting you know.
Oh, it probably is that. I don't think I've been on LinkedIn in a while. All right, can you guys see my screen okay?
Yep,
Yeah,
looks
looks
good.
good.
Awesome, thank you. So yeah, thank you, Rose, for the great introduction and for inviting me to speak here today. We have been working quite a bit with Werewolf over the last couple of years, and I recently started working with ZFS, and now I'm fully ZFS red pilled. I can't stop talking about ZFS. My coworkers can confirm that. I'm driving them crazy. So now I'm here to talk to all of you about ZFS. Rose kind of introduced me already, so I think we can skip right over this. And we'll talk briefly about how ASU is currently using Werewolf. I see a lot of familiar names in the chat here, so I'm sure many of you are already seen a slide similar to this. But we have grown since the last time. So we now have 4 clusters managed by Werewolf, around 1,000 or so nodes. That is up from the 3 clusters and 800 some odd nodes from a couple months ago. Been using Werewolf since 2023, and Sol is our top 500 system. This is our flagship cluster. This is what most researchers use. It is somehow still on the top 500 at number 484 now, so just barely on there, but still on there. We'd like to keep that number up, but unfortunately, other companies have a lot more money to buy H200 GPUs and such. We're still on A100s over there. But we do have a very good number in the green 500. We're up to number 77 there now. Phoenix is our legacy heterogeneous cluster made up of a lot of older Intel Broadwell CPUs, lots of faculty purchase condo nodes over there. Allo's our secure environment. That's the HIPAA aligned secure enclave. That's outside of the scope for today's talk. But we are now building a new AI cluster with 220 Gaudi 2 accelerators. This is going to be a little bit different from our other clusters. It's not going to be a Slurm batch scheduler. It's going to be Kubernetes-based, specifically K3s. It's going to be running a lot of AI-style workloads, so inference models or other Kubernetes-based AI workloads that could be run on these Gaudi 2s. But they're all booted with Werewolf nonetheless. A little brief overview of ZFS. Just curious, is anyone here currently using ZFS in any capacity? You could do something in chat or a simple hand raise. Or is ZFS brand new to everybody? Okay, we got a few people. So I am fairly new to ZFS myself. I've heard of it for a long time. I've seen people talk it up online as the greatest file system ever. I always thought they were kind of crazy until I actually started using it, and now I understand. ZFS is truly an amazing file system. Um, it was developed by Sun Microsystems in the early 2000s until Oracle acquired them in 2009. It is now open source through the OpenZFS project, but because of that Oracle purchasing, there's some weird licensing issues behind the scenes and fears of Oracle suing kernel maintainers if they ever put it into the Linux kernel. So unfortunately, it is still a separate kernel module that you have to build and install. Although I think some recent Ubuntu distributions will ship it with the Ubuntu distribution. So that's really cool. Hopefully, Enterprise Linux follows that at some point. But what makes ZFS so cool is it combines the software RAID capabilities with a volume manager that supports snapshot, dedupe, replication, self-healing operations, compression, and automatic mounting. Everything you'd want in a file system, ZFS seems to be able to do. So when we combine Werewolf with ZFS, we overcome a lot of the challenges with ZFS, especially ZFS as a root file system. There's some guides online that are quite lengthy on how to get ZFS as your root file system for an enterprise Linux-based system. It requires quite a bit of customization, and it doesn't look fun. I've thankfully never had to do that because all my systems are booted with Werewolf, where we pull the entire operating system into memory over the network before we start touching disks. So we can load the ZFS kernel modules in, configure the pools, and mount everything before we actually need to touch the disks and move the operating system over there. And it works perfectly with a stateless system because, like hardware RAID, ZFS configuration lives entirely on the disk. There's nothing that actually needs to stay persistent in the operating system. When you start up ZFS, it'll scan the disks, find those volumes that are there, and then import them automatically. Just like hardware RAID stores a small chunk on the disk that the RAID controller is able to detect and see that that's a RAID volume already. And ZFS handles all that mounting for us, so we don't need to worry about FS tab entries or statically defining disk configurations in nodes.conf, or even the huge pain point of making sure that the parent directory exists before you mount a path. That one has gotten me so many times in the past, but ZFS automatically does directory creation and saved me. Because of all these features, we can vastly enhance our ability to do stateful, stateless hybrid nodes when using ZFS. And what I mean by a hybrid system here is where the operating system itself is stateless. It's deleted every reboot, but there are parts of the operating system or parts of your data structures that are persistent. They're stateful. So while the entire kernel is wiped every boot, there's certain data that stays persistent. So why do we want to use a hybrid approach? Why would we want some data to stay persistent? Well, storing a large root file system in a RAM TempFS wastes RAM. As you've all seen, DRAM prices have quadrupled over the last couple months. So anything we can do to save memory helps. So we can move that root file system to a disk. That'll help save us a lot of memory. AI workloads benefit from a persistent local cache. So anything like a Hugging Face cache, your pre-downloaded models, it's really beneficial to keep those local to the node. If they're mounted over NFS, there can be huge delays trying to pull that down from the network in order to load it onto the accelerator. So having some sort of persistent cache is useful. Sure, you could re-download these every boot, but then you're wasting time re-downloading them from a network cache. Things like Kubernetes expect persistent per node files to exist. We found while setting up that new AI cluster that Kubernetes does not like it when your entire operating system is deleted every reboot. It was treating the nodes as if they were a brand new node every time, causing duplicate node entries. And that's because it expects certain things like your certificates and your node password to be persistent. Kubernetes is based on a persistent model. So if those can stay persistent across reboots, that benefits Kubernetes vastly. And we could manage those with overlays, but that's kind of a burden. I've already tried to do a couple per node SSH keys in Werewolf, and it's turned into this really ugly if statement. So it'd be nice if those could just stay across reboots. Partitioning disks is rather rigid and painful. I'm sure if you ever tried to add a partition when you already have a bunch of XFS file systems on a disk, you can know how much of a challenge that is. So we want something that provides memory efficiency and flexible persistence. So if we wanted to have a hybrid system here with stateful data and stateless OS, let's look at an example here where we have two 1 terabyte disks in a node, and we have 3 directories that need to persist across reboots. So in a traditional way, we would have the rootfs and RAM as a stateless tempfs file system. And then we could put one of these directories on the one disk and maybe split the other one up into to a couple of partitions so we could have those 2 directories. We'd have to mount those with fstab to make sure that those parent directories exist, so they're not going to overlap anything that might exist on the node already. We are wasting some memory here. If we have a large container in memory, that takes away some of the memory that's available to researchers. And there's no elasticity in this. If the varlib brancher directory in this example needs 1.1 terabytes, it can't have that because that other space is reserved for the Hugging Face cache over there. We could do something like this today with Ignition or the SG disk, I believe it's called, overlay. Use something like XFS or ext4 file systems, and this would work, but we don't have that elasticity. We could do this with the RAM saving way, where we move the root file system to a disk. The problem there is if we want it to be stateless, we have to wipe the disk every single reboot. So we could set aside one of these disks just for that root file system and then partition the other disk. This way, we're not wasting RAM, but we're wasting a lot of disk space. That root file system doesn't really need a whole terabyte, and then we're losing that elasticity still. Hugging Face cache there is down to just 500 gigs, and if it needs any more than that, it's kind of out of luck. Even if there's still space available on the disk, that would be reserved for another partition and file system there. We could do this all with NFS as well. Could mount these directories through NFS. That way they can persist across reboots. But then we get higher latency because we have to pull everything down from the network. And if we need per node mount points here, where Etsy Rancher node contains a unique key per node, then we'd have to have hundreds of mounts available in our NFS server, and it would just get really messy really fast. So what we can do is we can use ZFS to put everything onto one flexible pool here. So the RAM is reserved for researchers and system memory, and we format these disks with ZFS so we can create these flexible data sets out of that one pool. So no longer are we limited to just 1 terabyte, we have 2 terabytes available through a ZFS stripe, where the capacity there is shared between these. So the root file system and the Hugging Face cache and varlib brancher all share the same quota. I mean, we could set ZFS quotas on there, but we can allow them to expand as needed. So if varlib brancher needs a little bit more space, it has that available until something else consumes it. And with ZFS datasets, we don't have to worry about where they live on the disk. We don't have to rigidly partition our disk. It will handle where that data lives on the disk automatically, vastly saving us a lot of configuration time. I'm sure we could do something like this with MD-ADM or LVM, but I have a personal vendetta against MD-ADM. Couldn't tell you why. I just refuse to use it. And LVM, you're going to run into the same problems with rigid partitions compared to ZFS datasets. So this really gives us that elasticity where things can grow as needed without running into each other. We can also do this for another example here of a storage node where we actually are storing like persistent user data. This example here is for our BGFS cluster, where it's actually a stateless node booted with Werewolf. The operating system lives statelessly on one disk, whereas the entire user data set is a ZFS pool mounted at this location. What makes this really cool is we don't have to worry about operating system failures breaking our storage node. You know, we could practically rmrf/ and reboot the node and come up perfectly okay, so long as we don't touch that BGFS directory there. We don't have any wasted disk space. We don't have any wasted memory here. This is where ZFS really comes in. We had to build our most recent BGFS cluster this way because we didn't have hardware RAID controllers in these nodes. They're repurposed from an old Cumulus system, and they were just HBAs. They don't support RAID. So we needed some sort of software RAID solution that was flexible for our needs. And there's my cat. So traditionally, Werewolf boots with this image here. We pull the image and overlays directly into memory, and then Werewolf maintains state. As I've said numerous times in the past, this wastes system memory. So if we can pull that image into a block device, we're going to save a lot of memory. In a very extreme example here, we have this older compute node that only has 93 gigs of memory available. And so with that root file system in memory, that brings it down to 83 gigabytes available for research. So moving the root file system into disk gives 10% more memory available to jobs in this extreme example, and scaling across an entire cluster with around 1,000 nodes totaling 350 terabytes of RAM. If we put a 10 gigabyte Werewolf image into every single node, we lose 3% of our memory just storing redundant copies of those Werewolf images. So if we put those on disk, we can give that 3% or that 10 terabytes back to researchers. And researchers love having 10 terabytes of memory. So recent versions of Werewolf officially support moving the root file system to disk through the Ignition or sfdisk and makefs overlays. These are great. They work really, really well. If you have Draka configured and the proper packages installed, this is super easy to get set up and start working with. Initially, this was all Ignition based, but I complained enough about Ignition not being available for Rocky 8. So Jonathon found a beautiful solution to get this working on Rocky 8 with sfdisk there. This is great, but it does have its limitations. You can't do multi-disk operations where a single file system expands multiple disks, or what is it? Sorry, a RAID 1 or mirroring. Mirroring is the term I was thinking of. But this works based with arbitrary scripts in this wwwinit.d. So both Ignition and sfdisk just put scripts here. So we could put our own arbitrary scripts here, and we could do whatever we want in there. We could even configure ZFS dynamically in there. So if we put a script in here, let's call it zfs.sh, define a couple variables for our pool name and data set name, see if we have any ZFS pools available already. And if we don't, we'll go ahead and create our pool. We'll go ahead and destroy our root file system if that exists, and then recreate it. So this would happen every single reboot. We'll import our pools, destroy our root file system, and recreate our root file system. The mount point legacy there basically means don't set a specific path to mount this data set at. We will manually mount it later. We continue down. Sorry, it's really hard to put a bash script into a PowerPoint presentation. It's going to be split on 2 screens here. But then if we want to create other data sets, we can use a bash array here, loop through that, and see if it doesn't exist, to go ahead and create it and then set some properties. So on these non-root file systems, they are persistent. We are not deleting these. There's no ZFS destroy on these. That's only on the root file system. And so we can do this over and over and over and over again, and ZFS will gracefully destroy and recreate your root file system every single boot. So that create ZFS function, that could be kind of anything you want it to be. And I really like doing things dynamically, where I don't know exactly what's in the node, but I have some expectations about what's in the node. I know that these nodes should have 2 1 terabyte NVMe disks that I want to create a striped pool on, but I don't know what they're called. You know, there could be a 3rd NVMe in some of these, or a 4th, and maybe they're larger than a terabyte, maybe they're smaller than a terabyte. I'm not quite sure, but I know that I want the first 2 1 terabyte NVMEs to have this pool on them. So for every device in dev NVMe, let's figure out its size, grab its EUID path, check that its size is about a terabyte, maybe between 800 and 1200 gigs. And if it's not, we'll skip that disk. But otherwise, let's mark that disk as found. And once we find 2 of those, we'll mark those as our devices and create a ZFS pool on them. So this would obviously fail if you only have 1 NVMe, and we have found at least 1 node that did that. And we got into Dracket and said, oh yeah, it's missing a disk. We'll install that 2nd disk and get this thing booted. I like to use EUIDs or WWNs whenever I'm doing anything with ZFS. This is almost more of a personal preference. There's different ways to do this. As long as you don't use kernel device names, your dev SDAs or dev NVMe 0N1, those can change between reboots. And I like to be very specific with my disks and use the WWN that is burned into the firmware, so I know that will never change across reboots. So in a booted example of this, this is on one of those new AI cluster nodes where we have all of those different pools. It's a stripe across these two disks. We have over 2 TB or approximately 2 TB of disk space shared between these. And by using ZFS, we get all the benefits of ZFS, including compression. So we're effectively getting over our 2 TB disk limit by compressing some of that data. And some of this data is extremely compressible. Like the root file system would get a 1.75 compression ratio there, or 1.5 on the K3S data. Hugging Face cache is not very compressible data, and that's by design. It's already distributed in a very compressed state. But this is just one of the other benefits with ZFS here. On our storage node example, we have a very long and complex ZFS pool there, all associated with WWNs. But this operating system is stateless, while all of these disks are automatically imported at every boot with the ZFS import scan service and automatically mounted for us. This has proven to be pretty reliable. I have tried to break it. I have powered off the node and ripped out a couple drives and powered it back up, and ZFS still imported the pool, just in a bit of an unhealthy state. But as soon as I reinstalled those drives, it came right back up. So I have no fears about my operating system being stateless while I'm importing ZFS pools with important data on them. I've mentioned that ZFS is not in the Linux kernel, so you do have to install it and build the kernel modules for it. It's not too hard to do in a container file. I have a bit of an example here of doing this in Rocky Linux 9. As long as we clean up our old kernels first, this is pretty simple to do. We'll just grab the latest ZFS repository package, enable the latest, install ZFS in the ZFS Dracket package so we can work with ZFS inside of Dracket. We do have to manually get our kernel version. DKMS likes to use the value of uname-r as our kernel version when you're building in a container file. That's not necessarily the kernel we're building for. So I found it's easy to just query with RPM to grab the actual kernel version installed in this image. So when we do our DKMS build command, we can target that kernel specifically. So we'll build and install the kernel modules, disable the default import cache systemd service. That's going to look for a cache file if you have a stateful traditional node. But since we're not working with that, we need to do the import scan service instead, which scans your disks and imports the pools appropriately. So why does any of this matter? Like, why are we using ZFS? Well, we get all the benefits with compression, dedupe, quotas, automatic mounting. We get all the benefits of stateless booting, where we don't have drift between nodes. We can negate operating system breaking. We have simpler disk management with elastic capacity across our different data sets. We can easily scale this up if we needed to add another data set or another mount point with ZFS. It is far simpler to just say ZFS create this data set than it is to repartition your disk, shrink your XFS file system by removing it, deleting it, shrinking it, re-adding it. It's a very complex procedure compared to just ZFS create. We get the automatic mounting benefits, so I don't have to mess with fstab anymore. We don't have to worry about parent directories existing before mounting, and we get to return all of that memory to our researchers. So that is all I have for ZFS for you today. That example script I showed, the full one is on my GitHub there. It's been cut down heavily to fit into 2 slides on a PowerPoint presentation. There's dozens of sanity checks in there. Make sure that the pool is the pool that we're importing is the name we expect. Don't delete an unexpected ZFS volume that might contain data and all sorts of things. But yeah, thank you all for listening to this little rant about ZFS. I could go on for hours, but we'll give you back some time and answer any questions you might have. Yeah, Jonathan.
Awesome. I also am a ZFS advocate, so I'm really glad to see someone booting Werewolf with ZFS. I know that you talked about this in great detail, and somehow I missed like the crucial point and did not follow. Where are you actually writing the rootfs to?
So we're writing the root file system to a volume on the ZFS pool. So this my mouse coming? Yeah, my mouse comes through over there. So
Yeah. Yeah.
www.pool/www.root. I know it's a little confusing because it says mount point equals legacy. That just means it doesn't have a mount point defined through ZFS. We have to do mount-t ZFS www.pool/www.root/ or /new
And
root when we're doing this in Dracket.
at what point does it happen? Because I expect that to happen in a state where you wouldn't have ZFS running or working.
So that happens inside Dracket through the wwwinit.d. So this is pre-switch root, pre-systemd. This is after you pull the init ramfs in and you just have the init ramfs available to you.
Oh, and you just are able to include ZFS in the init ramfs when you build that.
Yes, if you have
Okay.
the ZFS Dracket package, it's pretty much all
Okay.
automatic.
That's what I missed. Okay. That was why I was confused because I didn't know you could do that. That's awesome.
All right. Any other questions, comments, concerns? You want to share some ZFS horror stories? All right. Well, I will stop my screen share then.
Yeah, this was really, really interesting. I didn't know that you can do some things statelessly, so like on boot, it's the new thing every time that goes right out, and then do something different at the same time to disk. That's what you were saying, right? Like so that
Exactly.
your
Yeah. Yeah.
image
There's
goes out statelessly, so it's the same every time, but then your storage gets to disk.
Yes, there's some things, especially in Kubernetes. There's a unique per node password that needs to be the same across reboots, and it's just a small text file and a couple certs. But if those change, then your Kubernetes manager or like Rancher is going to see it as a brand new node, even if the host name and IP address match. It has a different node password, so that needs to be persistent. So you just mount that path as on disk. So every time it comes up, it remounts it from disk, and so it doesn't change across reboots. Same thing with just cache, mount Hugging Face cache. That is, you don't want to be re-downloading that every time.
Ian requested that you post your repo in the info in the chat. I think you had like a QR code, but I don't know if you have like a link that you could just throw in the chat. That might be
Yeah,
helpful.
yeah,
There's
we'll post
a
that.
Werewolf extras or whatever thing. We should try and get the ZFS container file that you have there included in the examples side of the Werewolf node images repo too. I think that would be really useful to people. I love being able to pull that up. Whenever people are like, "Oh, it would be too hard to do that in a container file." If you can actually see one that works, you're like, "Oh, that's actually not that bad." But people just imagine this stuff being super complicated. So I love having those examples in there.
And it is complicated until you figure it out once, and then it becomes really simple. I fought with
Yeah.
DKMS for a very long time until I learned you can just specify the kernel version. Like, oh, it's that easy. Okay.
I want to know how long that took you. What do you mean a very long time? What's a very long time in Josh's world?
I remember having beef with DKMS for at least a year and trying everything I can do to avoid using DKMS until I came to ZFS, and there's no way around it. You have to have DKMS working.
Yeah.
Um,
You
I've,
only
I've
use
switched
DKMS in anger.
exactly.
So at any point did you like ask Claude Code or Chat GPT or whatever to like help you with the issue? Do you have
Yes, yeah, of course. They're good tools, and I'm surprised at how much they know about Werewolf already. And in
Yeah.
fact, in one of my system prompts, I even have like I use Werewolf on the regular. Please recommend things related to Werewolf, and it does a pretty good job.
Oh, yeah.
Most scripts I write, I end up running it through Claude or something. Just say, format this, fix my typos, fix the spacing, and it just makes it look a little prettier. But the core logic kind of has to be hand done. You need a human to think about your actual needs compared to whatever an AI says.
Yeah. Come off of mute, Joe. Tell us what's up.
Yeah, I was just pouring salt in the wound. This was a great presentation, Josh. Just pointing out that yeah, the NVIDIA driver installation guide, which was not anywhere near as good like 2 years ago, covers this exact thing.
So yeah, that's one of
So
the
yeah,
first things
that
I
could have
fought with
saved you all the
DKMS
pain.
on. See,
Right.
I ended up
Exactly.
switching
This
to
could have saved
the
you all.
run file installation because the run file asks you
Yep.
for a kernel version right there, and the run file just works. So that's what we've been doing for the last 3 years.
Josh, did you see George's comment in here? Can you see the comments in the chat?
Oh, there they are. I don't think I could see these while I was presenting. Thanks,
Yeah,
Zoom.
it's hard. Yeah.
Yeah, you have to open them like as a separate window or something.
Mhm.
Oh, using resources now. Okay. That's that's really cool. That would be a great way to not just bake everything into a bash script. I really like that. I
Well,
haven't
this
messed around with
bash
resources very
to
much.
actually run this, but yeah, there's still a bash script in the back end of this, similar to what you have actually.
Yeah, but it can be templated and be a little bit more dynamic. I like that. If you have that script with the templating and everything you want to share, I'd love to see it.
Sure, I'll find it somewhere for sure.
Awesome. Thanks, George. So Josh, you said that this so Kubernetes was kind of the inspiration to figure this out. Is that the only kind of like use case that this makes sense with, or is it for like for everything?
I'm sure there's going to be people that have use cases that could benefit with this that I can't even think of. Our ZFS exploration started with needing a BGFS cluster that didn't have RAID controllers in it. So we needed to do software RAID somehow. And I refused to use MD-ADM. So it kind of left us with no choice but ZFS. I thought about just statefully installing an operating system and managing it with Ansible or Salt, but everything else we have is Werewolf managed. So it seemed easier to just, well, let's see if we can Werewolf manage this. And sure enough, you can very easily. The BGFS doesn't care where your root file system is. It doesn't care that it's stateless. It just needs config files that you can manage with an overlay, and it needs the storage, which you can easily manage with ZFS. Everything else is ephemeral in a way. You can upgrade and downgrade the operating system very seamlessly. I like
Yeah.
your comment there, Joseph. Yeah, you haven't lived until kernel updates break your file system.
Yeah, running out of tree file systems, it's only for the bold and foolish.
Yeah,
I say
Kubernetes
as
is
a ZFS user.
Kubernetes is where this really needed to take off. And it started as, okay, we need one path to be static. That's easy enough to do. Well, actually, now we need a second path to be persistent, and actually now we need a third, and maybe a fourth too. And that's where it starts to become easier to just start creating data sets instead of partitions.
Yeah.
So
You mentioned operating systems that have ZFS built in. Ubuntu, like you said, has been doing it for a little while. Another place it's not quite as relevant to Werewolf, but if people just want to have a platform for ZFS, I use Proxmox for my ZFS environment, and um, they have ZFS built into their kernel, which is another good place to get it.
very nice.
Wait, so that's part of the issue is that so I guess it would be Rel, Rocky, other flavors like ZFS is not part of the kernel?
Yeah, the ZFS, the OpenZFS project releases code under a license called the CDDL, which is, from some vantage points, explicitly and intentionally non-GPL compatible so that it cannot be merged into the Linux kernel. And there is then a perspective of whether, like, it's always legal for an individual person or an admin or whatever to build them together on a system. But there's been a question of whether it is legal for a distribution to do that and then distribute the built version. And different companies, lawyers come to different conclusions on that question.
Okay, yeah, I know Shane had popped that in there, so thank you for like the verbal explanations.
Yep.
It helped me when I was reading that. Okay, that's interesting. So then how do you do that, Josh? Do you just do it like with an Ansible script or something like that, or you just do it once and it's done, or do you have to how often do you have to keep figuring out the kernel?
Oh, for the ZFS modules?
Yeah.
We do just do it in the container file. So every time we rebuild the container or the node image, we reinstall ZFS and push it
So
out.
Okay,
that's what
you build it,
DKMS
it's
is.
yours. Okay,
Yeah.
sorry.
DKMS is the dynamic kernel module system. I think is what it stands for. And so it's building the kernel module every time you update the kernel on a normal dynamic system, but then you can also use it to build it during the container build.
And
I'll
so
say I
why?
like.
Yeah, go ahead.
I was gonna say I like BGFS's implementation where it's not exactly a DKMS module. Just every time you start the BGFS client, it runs through a make file to build its kernel module that way. That works really well. So every time you update your kernel, you just restart the service and it works.
I think GPFS does that now too, though I'm not certain. That you can also build
It
an
doesn't
RPM
for
for it
us.
catastatically. Okay. Maybe
But we're
I'm
also
mixing it
on
up
an
with
older
BGFS then.
version 5 build.
Okay.
Our storage is version 5. You can't
Right.
you can't get like 6 features unless your storage supports it.
So Ian, you had said that you've been using it a long time, or Ubuntu's been using it for a long time. Like how do they get away with that? Is that because like people don't pay for it, or what? Like what help me understand that. Go
It's
ahead.
just a legal decision. Like Ubuntu's lawyers decided that they could do it.
They don't care. Okay.
Yeah.
I mean, yeah, they looked at the licensing and just said, people are asking for it, we'll do it. Um, and what Ubuntu does is if it throws something in the system that violates um, the you can put something in there, you just have to tag it as saying this taints the kernel because it's not pure open source. So it's like we can use the CDDL license that Sun has, which is open-ish, but because it doesn't adhere to the strict requirements of a fully open source system, you just have to know that it's there. That's all. I highly doubt they'll get sued
Yeah.
because CDDL is open. It's just not as open as the people who hold the strings to open wish it would be.
It's differently open.
Yeah, I mean, there's so many different open
Yeah.
licenses, right?
So open meaning like you can have it, you can use it, and you can do what you want with it, but you can't like package it and resell it.
No,
You can package.
yeah, it's you have the strict open source people that say you have to adhere to this license. And if it's not this license, it's not fully open. And then you have all these other companies that have their own open licenses that just don't meet that exact parameter. So it's still fully open. It just doesn't meet the very strict eye of which open license is it?
It's GPL2
Yeah,
and CDDL.
well, I mean, but I'm saying so it's the GPL
Yeah.
license for Linux, right? Linux falls under the GPL mandate, GPL2 now. CDDL does not match GPL2. It's a different license, but it's still just as open. So you just have to make a declaration in there that if you're including something that's not GPL2, you have to state it. This is not GPL2. That's all.
Yeah, there's no restriction on distributing or commercializing OpenZFS, and there's no restriction on distributing or commercializing the Linux kernel, but the two licenses are not compatible.
Right.
So there's a question of whether it's okay to combine them into a single thing and distribute that. That's where the issue comes.
Yeah, and as pointed out, the BSD license does not care. So
Yeah.
you can include CDDL in BSD Linux, and you're fine. There's no complaints. There's the Open Apache license. So that's another one there's things built using that, which some distros will not include by default because it's not GPL2.
Complicated.
It's an annoyance for everybody here on the screen,
Exactly.
right? It's just an annoyance. That's what it is.
Well, I mean, somebody's got to have a job, right?
True.
I'd like to think that if Oracle ever tried to sue, that the backlash would just destroy Oracle as a company. But I can only dream. If they just open source everything,
Yeah.
drop all the licenses, the world would be a better place.
Yeah. But Larry, so I mean, they wouldn't be able to buy Netflix. So, wow.
I think the main thing, though, for people on the call, if you're not using ZFS yet, don't be afraid of the licensing issues. The licensing issues don't affect you, except for that it makes things more complex to deploy. It's only
Right.
for the distributions that the legal stuff matters.
Yep. And for those not using ZFS, you won't go back once you do it.
Yeah.
You may not use it for everything, but the days of wrestling with other tools, you'll be like, why? Why did I bother?
People
And
say
the
that
Well
fact,
about
said.
Werewolf too. It's like a
yeah,
good, like a good combination.
yeah, yes, 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 as discussed yesterday. Yes,
Yeah,
things
yeah.
just work. And there have been many online examples of things happening to ZFS storage arrays where if it was anything else, it would be catastrophic failure. And then slow down, step back, start using your ZFS tools, and oh, look, it works again.
Yeah, I did. The first time I started using ZFS, we had so we were running PGFS on ZFS, and we had an issue where we couldn't recover after a power failure, and it would just try and mount the pool or whatever, bring the pool online, and it would just hang. And we eventually did work with, a guy that was selling ZFS support, and we brought him in, and he got us in with some of the developers to help us figure out what was going on. And the reality was, if we had just let it run, it would
Yep.
have recovered and been fine. But
Yep.
we would let it run for like a minute and be like, "Oh, it's hung," and then kill it.
Yep. Yeah.
And so the only real bug was that it wasn't reporting what it was doing
Right.
during this long mount. But yeah, it's a really stable system. It's great.
Well, I posted earlier in the comments, nothing like having your bosses sitting over your shoulders. So we had uh, a large storage array at the time. Um, the person who designed it followed the best practices from Sun at the time, which was every user should have their own file system, which was a pain because all the snapshots just increased the number of file systems it was trying to mount every time on a reboot. And it reached a point where it would fail mounting at least one file system. And so everything would hang because ZFS is like, oh, something's wrong. And we knew every reboot, oh, it's going to fail. And so I'm sitting there down in our basement server room with both bosses watching. I'm like, it's going to fail. I know it's going to fail. I don't know where. I know it's going to fail, and I'll stop it. And I'll go in there and use ZFS to fix it, and we'll be fine. And they just had to watch every time, like once a month. I'm like, please, this would be really easy if you weren't here.
I feel like CFS has come a long way in recent years. Like the 2.4 release seems really, really stable. I'm curious, what version of ZFS was that?
It was early, like probably a one version, because we were still
Okay.
using Solaris 10. I've played with it from day one, and I actually worked with some people at Nexenta when when they had their free community version, which was really nice. It had a nice GUI, made it really easy to manage things. There's also a product from this guy in Germany that is basically just a web-based interface, mostly was using Perl scripts. I know he's updated since then, and I actually worked with him early on to make that available and test it against a number of things, including Ubuntu deployment, because he originally just built it primarily over Open Solaris. And so yeah, for like 10 years, I had a free license. Let's see if I can find it for you. It's you can do a lot freely. The license itself is not that expensive. Um, and he's very active in the OmniOS community.
That's a web interface for configuring ZFS.
Hmm.
Sounds pretty cool.
So
Do
how
love
did
a good web interface.
so it's an open source project. How did they like what did they do? Do they have a Slack? Do they have like a website? Like how do they?
There's an open ZFS Slack, yeah, and then
There
there's a
is,
mailing list.
yeah, and a mailing.
Yeah.
Okay.
A big, huge GitHub.
And a big, huge GitHub. Oh, that's cool. So it's actively maintained. How old is it?
That's real old.
Yeah.
Real old? Okay. Like as old as all of us.
Some of us.
Some of us. That's awesome.
It is.
It depends on what you're talking about. If you're talking about ZFS itself, like it goes way back into Solaris, and then it was spun out
Oh,
during
that's right. Yeah, he said
the
that.
Oracle acquisition, I think.
That's right. That's right. Okay, Ian, were you looking for something that you were going to share
I
right
found
now?
it. I'm going to put it in right now.
Yay.
He's based out of Germany, so this is the English version, but he actually has the native site is German. Christopher, if you're curious.
Hey, I'll check that out.
Christian. Yeah, it's a super lightweight. And I believe you can license some of the plugins piecemeal, and he's added some really cool capabilities, as well as just, monitoring things. So he has the pro extensions, which he makes it really easy to configure snapshot backups. And he had talked at one point of doing HA capabilities. I don't know if he ever got that far.
Yeah, we're talking about that too. We're going to have to talk about that a different time because we are perfectly at time. You guys, what a great conversation. Beautiful wug. Thank you everybody for coming. Josh, thank you for getting the topic and conversation started. This was a great one. Glad that you brought it up.
Awesome.
Yeah, thanks for having me. And turned into a little bit more of a CFS than a Werewolf conversation, but
yeah.
I'm happy about that.
ZFS, or sorry, Werewolf is assumed.
Right,
There we
right.
go. Awesome. All right. Well, thanks again, everybody. I look forward to seeing you same time, same place next month.
Yep.
Later, everybody.
Okay. Have a great one.
All.
Bye.